right. Hi, my name is Jessica Voss, and this is Anne McLean, and we are here today helping the designers of the Orion capsule evaluate the ability to protect their crew from radiation. Radiation, as you know, is really harmful, and so the whole point is for us to get into a really cool little shelter and take all the equipment we have in this capsule and put it over us as best as possible. And we have to make sure it's stowed and that we are safe and we have everything we need in terms of supplies down in this awesome little bay.
Yeah, going to space is hard and going to deep space is harder. And the technologies that we're going to need to successfully get to Mars have been being developed for many years, and it's going to take many tests like this one over many years by a large group of people in order to make that mission successful in the 2030s. So we're excited to get there, and we're working every day toward that goal.
You're going into an environment that's completely unforgiving. The temperatures that we're seeing on the spacecraft have not been seen by any other spacecraft ever before.
The scariest thing about the sun is the unknown. We see it every day, but we see it from 93 million miles away.
This first perihelion we're going into, we have very minimal contact. All we can get is a tone.
I'm going to be waiting on the edge of my seat for those beacon tones.
The sun-facing side will be exposed in excess of 2,500 degrees Fahrenheit.
We're going past the stratosphere and even farther, some 60 to 600 miles above Earth. Our atmosphere slowly gives way to space. This region, the ionosphere, is home to the aurora, but is also increasingly a key part of the human domain. It houses not only astronauts, but radio signals used to guide airplanes and ships, and many satellites. And yet, the ionosphere is not well understood. To explore this area of near-Earth space, NASA and UC Berkeley built the Ionospheric Connection Explorer, or ICON. ICON's task is to help us understand just what causes the constant changes we see in the ionosphere. The more we understand, the more we can protect our assets in space. From a position close to Earth, ICON samples variations in the ionosphere over the course of hours, days, and seasons. The mission will investigate how the ionosphere reacts to our planet's weather rising up from below, as well as space weather from above. A key set of the mission's observations focus on the most eye-catching phenomena visible in the ionosphere: airglow, colorful bands of plasma caused by solar radiation. ICON will use specialized technology to track how this plasma is moving through the ionosphere. As ICON learns more about the relationship linking Earth's atmosphere and the space environment, the information will help improve the ability to predict conditions in the ionosphere, one more important step in protecting ourselves as we venture farther and farther from home.